In this video, we will be adding complex numbers in polar form. Here we have the expression 4 root 2 times cosine of 3 pi over 4 plus I sine of 3 pi over 4 plus 3 times cosine of pi over 2 plus I sine of pi over 2, and we want to evaluate its sum. Since we're given the complex numbers in polar form, before adding, we must convert them into rectangular form. Recall that to find the a and b values for the rectangular form, a plus bi of a complex number, we use the formulas a equals r times cosine of theta and b equals r times sine of theta, where r is the modulus and theta is the argument of the number. So for 4 root 2 times cosine of 3 pi over 4 plus I sine of 3 pi over 4, the a value is calculated as 4 root 2 cosine of 3 pi over 4, and the b value is calculated as 4 root 2 times sine 3 pi over 4. And for a, that would equal to 4 root 2 times negative root 2 over 2, giving us negative 4. And for b, it's 4 root 2 times root 2 over 2, giving us 4. So the rectangular form of this number is negative 4 plus 4i. We apply the same two formulas to 3 times cosine of pi over 2 plus I sine of pi over 2. This gives us that a equals 3 times cosine of pi over 2 and b equals 3 times sine pi over 2. So for a, that equals 3 times 0, which gives us 0, and for b, that equals 3 times 1, which equals 3. So the rectangular form of this number is equal to 3i. Now we can finally add these two numbers together. So we have negative 4 plus 4i plus 3i, and then combining like terms gives us negative 4 plus bracket 4 plus 3i, which equals negative 4 plus 7i. But we're not done yet because we still need to convert this back into polar form. To do so, recall the formulas for the modulus and argument. R equals the square root of a squared plus b squared, and theta equals the arctan of b over a. So in this example, our a value is negative 4 and our b value is 7. This gives us that r equals the square root of negative 4 all squared plus 7 squared, which equals the square root of 16 plus 49, which equals square root of 65. While for theta, we have arctan of 7 over negative 4, and typing it into our calculator gives us negative 1.05. But if we plot negative 4 plus 7i on the complex plane, we can see that this point is in quadrant 2, while the angle, negative 1.05 radians, is in quadrant 4. So we have to add an extra pi radians to negative 1.05 radians to get our actual theta, giving us our argument of 2.09 radians. So the sum of this expression is square root of 65 times cosine of 2.09 plus I sine of 2.09.